Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about machine learning reliability. This topic is based on a tech blog with the title How to Monitor a Recommender System, written by the engineering team from Tubi TV. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and technical angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Tubi TV is a popular streaming service, offering a wide variety of movies and TV shows to viewers for free. The platform operates on an ad-supported model, allowing users to access content without subscription fees. Given the vast library of content available, Tubi TV relies heavily on its recommendation system to enhance user experience and engagement. A robust recommendation system is crucial for Tubi TV's business because it helps in curating personalized content for each viewer, ensuring that they can easily discover and enjoy shows and movies that match their preferences. This not only keeps users engaged, but also increases the time they spend on the platform, ultimately driving ad revenue and user satisfaction. Monitoring the recommender system is crucial for Tubi TV's business. If the recommender system fails, users may struggle to find appealing content. For example, if a user who loves action movies is suddenly being recommended a lot on romantic comedies, they might become frustrated and leave the platform eventually. This customer dissatisfaction can also spread through word of mouth, further damaging Tubi TV's reputation and hurting the company's brand and impacting long-term revenue. Therefore, effective monitoring and ensuring the recommendation system works as expected is essential for Tubi TV's success in this competitive streaming market. Monitoring the recommendation system is not trivial work. Unlike those fixed mechanical software components, recommendation systems are unique and typically based on machine learning models, which is trained on previous customers' engagement data and various other inputs. These models often function like a black box, and their behaviors sometimes can be less predictable. Common software engineering monitoring practices, such as ensuring the recommendation results are returned within a request SLA, they are helpful, but they are far from being complete. The change of recommendation quality is more crucial in this context, making effective monitoring recommendation system a significant challenge to be addressed. Now that we've understood the business problem to solve, let's dive into the technical side to see what could be a good solution. In order to detect the change in recommendation quality, the team decided to identify the places where errors could occur that impact the recommendation quality. Once they identify those spaces, then dedicated monitoring solutions can be proposed. So first, here is an overall recommendation processes. The first three steps occur online, meaning that they happen when a user makes a request. The first step is that the client side sends the user information to the backend, which then forwards it to the recommender server. The second step is that the recommender server processes the user information through models and returns the results, which sent over to the backend side with some post-processings. The third step is that post-processing rules are applied to the results. For example, some unavailable content may be removed. And then the backend returns the recommendations to the client side. Besides the first three steps, which are online, the fourth step runs in parallel and is more offline, meaning that the machine learning models are trained on data asynchronously with user request. And these trained models are then synchronized to the recommender server to get it updated. With a comprehensive understanding of this process, the team proposes monitoring three key types of data for the recommender system. The data passed to the model used for inference prediction, the final recommendation results that appear on the user's screen, and the model training data that determines the quality of the model. Let's look at each of these data types one by one. The first data type is the data passed to the model. This is the earliest step in the recommender system workflow. There is a principle says garbage in, garbage out, and it applies here. Once an error occurs in this stage, the recommendations will deteriorate due to the incorrect information provided. This kind of issue is hard to identify because it usually happens in real time, meaning that it was sent by the client side, received by the back end, and then passed to the recommender system in a matter of hundreds of milliseconds. Additionally, the client side and the back-end systems may not be sensitive to abnormal changes in those inputs. Therefore, it is important to log and monitor the data passed from the client side. For example, tracking the percentage of users with a specific language passed into the models can help determine if this number is stable and expected over a given period. If the number changes dramatically over a period of time which is not expecting a change, the alerting system can be triggered to escalate for investigation. The second data type is about final recommendation results to users. This is determined by the recommender models and the post-processing steps. The team needs to identify important properties based on the final recommendation results and monitor them. For instance, the ratio of each content type among the recommendation results should be more or less stable. And these monitoring metrics require a deep understanding of the business, knowing which aspects matter the most to the user experience on each of the specific recommendation surface, and then getting that defined metrics into monitoring system. The third data type is about the quality of the training data. This determines both the quality of the model and then lead to the quality of the recommendations results. The team found that key properties of the training data should not change much over time, and any significant changes usually indicate potential issues. For example, if there were a sudden change in the number of rows of training data, or the ratio of positive labels dramatic change, or the proportion of missing values in selected features, they all could indicate issues with how the training data is prepared. And then those would warrant some further investigation. With these three data types under monitoring, the team can establish a robust monitoring system. Key considerations including ensuring the monitoring system's timeliness, scalability of monitored metrics without impacting each other, and the flexibility to change given the dynamic nature of potential issues and continuous business context change. Existing monitors may need to be adjusted over time, and new monitors may need to be added to capture new types of issues. Besides these considerations, there is one practical piece of advice the team shared, is to scale the monitoring efforts by delegating the actual monitoring metrics and ownership to each business domain owner. Business domain owners are responsible for managing the alerts, setting up alert threshold, and identifying potential issues, while the central team builds the platform to enable them to do so. This approach is crucial because domain owners are closest to the business context, and this makes them better positioned to define and iterate on customized metrics effectively. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed how to build an effective monitoring mechanism for a recommender system. We explored the various processes involved in the recommendation system and how the Tubi TV Engineering team developed their monitoring flow accordingly. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.